graphical representations of the graph coloring of the map of Australia. Initial state. The stage or the process in which no value is assigned to the variables. All the variables are blank. The initial state, initial condition. Successor state or intermediate state. The assignment of any color to any of the variables are classified into two groups. The first group has at least one value. The second group of the variable must have empty values. Some of the variables are assigned with values, and some of other variables are not assigned with any of the values from the domain. Such type of the state is called successor state or intermediate state. Gone state, the last state. All the variables will be assigned with some values from the domain without any repetitions and without any violations. The state in which the final solution is obtained, that state is called gone state. Let us move to the next slide. Backtracking search. This is the one of the famous technique of the constraint satisfiable problems. And let us start with some of the important characteristics of backtracking search. The first one is the binary solution appears at depth n with n variables. One solution can appear at depth n with n variables. The number of the nodes is n. The depth is at the level n. We use the depth first search technique. This is the one famous technique which will be applied in the backtracking search. The second point is the depth first search for constraint satisfiable with the single variable assignment is called backtracking search. Any of the constraint types cannot be considered. The first constraint type means that unary constraint will be used in backtracking search. Any single variable will be assigned with a one value in backtracking search. Backtracking search is the basic uninformed algorithm, and this is the one type of the algorithm. In this algorithm, general purpose search algorithm, and which operate in brute force way. Brute force technique is used in this algorithm. Such type of algorithm used in the brute force search is called uninformed search algorithm. And this backtracking search can be used to solve n queen problems when the value of n is 25. And let us move to the next slide. And this is the algorithm for the back search, and we can understand this algorithm by considering some examples. Depth first search. This is the very simple and very popular search algorithm, and there are some steps we have to apply. Let us see these steps. We have to move or visit the deface unexpanded or unvisited node. We have to move by considering only the depth without considering the height. We have to move in depth only for unvisited node edges. The second point is that we have to generate only one sign at a time. This depth first search generate only one sign at a time. At a time means that at one process. Goal test is done when a node is inserted. Whenever a node is inserted in that graph, we have to perform the goal test. For the CSP problem, goal test is performed at the bottom, at the last 11. Goal test is performed to get or to give the Stevens solution. And let us move to the next slide. This is the graphical representations for the example of default source, and we can use the default source in this graph. We have to start searching from the node A, and we have to move from node A to the node B. From this node A to the node B for the searching of the node L. Here node L is the solution, and in this problem we have to search a node whose value is L. That is the condition. We will start searching from the node A to the node. We will start searching the node L from the root node A, and we have to move from node A to the node B in the left branch. And after reaching at the node B, we can compare the value N and the value B, but the value L is not obtained up to B, and we have to move further to the left branch. And after moving to the left side branch with the node F, and we compare the value F and L, we do not find the output L. And from F to B, we have to move back. We reach that end. No branch is available. That is why we have to move back to the node B, to the previous node. From the node B, we have to check if there are some other probable branches. Here, there are another branch moving to the node C, and from the node C we have to searching by moving to the left branch, and we arrived at node K, and K and the value K and the character L is compared. We get inequality. K is not equivalent to L. We do not find the character L or the value L, and we have to move back to the node Z, and after that we have to move to the right branch, and we reach at the node with letter L. Now the condition is satisfied, and we have to stop here. This is what represents the output. After moving to the left branch key, we have to move back to the previous node C. This process is called backtrack. At the time of the tracking, we moved back. This process is called backtracking. And after that, we have to move to the right branch to arrive at the node L, which represents the output. Such type of the searching is called a default search. In this search algorithm, all the variables are represented by nodes. The condition is here. The condition is the finding node must be character L. That is the condition. And after this example, let us move to the next slide. How we can improve the backtracking search algorithm. There are some cases or some conditions we can improve the backtracking search algorithms. There are some demerits for the backtracking search. It takes more time, it takes more memory. That is why this backtracking algorithm has demerits. And this demerits can be improved by considering into three cases. The first case is which variable should be assigned next. After assigning a one value to the variable, and in the next step, which variable will be considered for the assignment. This is the first case. If we select the variable wisely for the assignment of any value from the domain, we can at least improve the backtracking search efficiency. The second case is the order in which the value should be used. The first value or second value, we have to select wisely the order of the assignment of the value from the domain. If we consider wisely in this second case, we can improve the efficiency